Welcome to This Week in Science, this week's podcast broadcast, everyone. Oh my gosh, it's always at the beginning of the show when I'm trying to make things happen that something like Facebook just decides it doesn't want to be a part of things. But I hope I fixed it right now. I clicked buttons as we're getting going. Hey, I'm all alone tonight. We're going to talk about science. This is your evening science road trip. I don't know. I'm making things up. I am going to be here tonight to talk about science. And this is the part of the show where I tell you that if I make mistakes, if things get messed up, if there need to be deletions and all that stuff, then Rachel is going to be fabulous and take them out for the podcast version. But you all who are watching this video version are getting the whole uncut real deal. And that is all there is to that. So, how's my audio? Are we 5 by 5? Are we ready to science chat? Yeah. No, yeah. What was it? What was my old show? Dr. Geeky Science Hour. And then I also had the science chat. That was when I did for a really long time. Yeah, I'm sounding all right. Yay. Woohoo, woohoo. Okay, so thank you for the validation of my audio quality. Let's begin the show. I don't have to go into my full screen because I was already in full screen. So, yes, my friends, we are starting the show in 3, 2. This is TWIS. This Week in Science, episode number 1040. Am I right? Did I get it wrong? Did I delete things? What just happened? My whole thing changed. No, 1041. I thought it was. What happened there? Something got deleted. Okay. Ooh. I made a number wrong, and it's not 1040. It's 1041 because next week is 1042. Do. What you gonna do? I knew it. Rachel's gonna edit this out. La 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 la. Okay. 3, 2. This is TWIS. This Week in Science, episode number 1041, recorded on Wednesday, December 10th, 2025. Tilting at Tumbleweeds. Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your head with space gum, dinosaur dots, and necroprinter. But first, disclaimer. What got more attention this week? That a wind turbine dropped a massive blade into a cranberry bog, or that a U.S. district judge said tilting at windmills is arbitrary and capricious? If you heard the stories at all, you're among the few paying attention to the to-dos, the kerfuffles, and all the things that this week gave a win to wind power. Woo. Perhaps we'll see a few more whirling wonders in the world. Just because someone doesn't like it doesn't mean they can stop it. Just like This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Thank you. Oh my gosh. I did that. I clicked a button. Good science, everyone. Welcome to this week's episode of This Week in Science. Thank you for joining me. It's just me and you for this week's adventure through curiosity. There's so much out there, and I am really excited about getting to talk about it with you. Yes. So I have stories tonight that I've brought that I picked out this last week that I thought would be fun and thought inducing, curiosity developing. What are they? Space gum, dinosaur dots, elephants and bees, kids and dogs, glyphosate ghostwriting, tumbling tumblebots, and a necro printer. And I will get to that by the end of the show. All of it, and I don't know, maybe more if you have things you want to talk about. We'll talk about these stories. All of you in the chat room, if you're here, we're talking. So if you have thoughts and questions, I will see what I can do to make sure that they're brought into the conversation because I'm talking with you. Okay, if this is your first time joining This Week in Science, I want to I'm not reminding you, I'm telling you, I'm reminding others that you can get TWIS as a podcast. We are all places that podcasts are found. Look for This Week in Science, subscribe yourself, subscribe your friends, and then you'll never miss an episode. Also, we are weekly on YouTube, Twitch, and Facebook, 8 p.m. ish Pacific time. And those episodes are there. You can join live. You can watch them later. It's so much fun. But twis.org is the website where you can go to find out about the latest episodes, find out show notes, get links to our Zazzle store, our Patreon, and find out about every episode. So if you haven't subscribed yet, you can go to twis.org, get what you need from the latest episode, and then hopefully we'll find you in one of our live shows or as a subscriber later. All right, everybody. Bump. Is it time for the science? I wish I had my co-hosts here to say, yes, it's time for the science. Okay, starting off the show, let's talk about space because I like space. All right. We're starting with sugar, gum, and dust. On an asteroid. Yes, NASA's OSIRIS-REx spacecraft went into space to the asteroid Bennu. It was a sample return mission. It grabbed bits of the little asteroid that could, brought them back, and we have been looking at these samples, the pristine samples. They're going through trouble to say that they're pristine. Are there questions? But this mission, this spacecraft, all this stuff, there's been a lot of information previously about amino acids, complex carbohydrates, or like complex molecules being found on the surface of Bennu. This new series of papers, 3 papers published this week, Nature Geosciences and Nature Astronomy, they found sugars. So I'm going to say sugars, gum, and a lot of dust. So we'll get into that now, right? Sugars, ribose and glucose. This is the first time a 6-carbon glucose ring has been discovered from anything in space. So this, yes, Paul Disney, a sweet story, is telling us that we've got ribose and glucose on this asteroid. It hasn't been broken down. It's there. It's extraterrestrial in nature. Asteroids and comets were around. This Bennu was around in the early solar system. So what we're seeing on the surface of Bennu is potentially a time capsule from the very early solar system, indicating that ribose, which is an ingredient in ribonucleic acid, RNA, was present. There was no DNA, no deoxyribonucleic acid that was discovered, but the ribonucleic acid is interesting because There is a hypothesis that suggests that life started on Earth with RNA. It's the RNA life hypothesis. Oh, yeah, right. My shared image. I took it. I should have taken it down. Thank you, Kevin. I just left it up there as I was talking. This is me on my own, um, just talking. Thanks, friends. Okay. But anyway, this wonderful study that has been published in Nature Geoscience, the researchers from Japan have been able to suggest that, okay, we've got all five nucleobases, phosphates. These were already found in samples from Bennu. So, all of the ingredients necessary to form DNA and RNA, now ribose, which is also part of RNA and DNA. So, everything is there. And then additionally, they found glucose, which is sugar, which is energy for life. None of it broken down, nothing indicates life on Bennu whatsoever at all. But if all of these molecules, these components were hanging around and have been hanging around since the very, very early universe, it just bolsters support for how life got its start here on Earth. That it's not a surprise, that it's been there all along. All of the chemical reactions possible were there. So anyway, yeah. But who dropped their gum on Bennu? No, I'm kidding. It's not chewing gum. It's a polymer gum. So a sticky gum-like substance that has come from interactions between carbomer and nitrogen and oxygen and years of chaotic chemical reactions. These researchers were able to discover this um, these sheets of this molecule that they say looks as though it, and this was I think electron micrograph imaging, but they were able to confirm that this substance would have been kind of sticky and pliable and not a hard rock like substance. I mean, it's in space now. So it suggests that these interesting polymers and chemical reactions have been taking place on the surface of Bennu for a very long time. And why? Why? How? What's going on there? Anyway, the researchers are excited because this has never been seen before. They say that they see the same kinds of chemical groups that occur in polyurethane on Earth. And so they're suggesting this is their quote, making this material from Bennu something akin to a space plastic. But it's not like an orderly plastic, it's random. And like I said, chaotic. It's hodgepodge. There's lots of elements and composition. It's just particle to particle, and so it has an interesting nature that hasn't been seen before. This is the first time we've seen uh, this composition, this component. And so, uh, is it going to be on other asteroids? We don't know. How might it have impacted the formation of life? We've been talking about the RNA life hypothesis. There's another hypothesis suggesting that life got its start within little tiny clay formed bubbles where there were little holes in clay, and the clay basically formed the outer edge of a cell. So there was no cell membrane, but the clay basically held solvent and components like ribose and all this stuff and allowed chemical reactions to take place. But what if it was clay and possibly a compound like this? Maybe there was an early plastic. Maybe plastic life, it really is where we came from. I don't know. Paul Disney, Bennu is not covered in space boogers. No, unless it's plastic boogers and dust. And oh my gosh, you made me sneeze. Okay, anyway, Bennu might make people allergic just like me. Okay, Nature Astronomy and Nguyen of NASA's Johnson Space Center in Houston, they looked at pre-solar grains and they found these rock types and tried to figure a bunch of stuff out. But anyway, they had 6 times the amount of supernova dust than any other studied astromaterial. And so they think that the parent body of Bennu, that Bennu came from, it might have come from a part of the protoplanetary disk that was enriched with the dust of dying stars. It's really cool. So, lots of dust, sugar, weird gum, and new insights about the beginnings of our solar system, and additionally, the uh, potential for chemical reactions that could have led to the chemical reactions upon which life depends. Um, all this stuff found on Bennu. Where else is it? This is so exciting. It's pretty cool. Anyway, I think it's very interesting that we have these sugars that are I don't know. It's pretty sweet. Bennu's pretty sweet. Um, these sugars being present, especially the glucose is interesting as well, because if glucose is just there for whatever reason, how, you know, it's available, chemically available. Glucose has a ton of energy. We know that biochemistry is like based on so much glucose metabolism. Um, I don't know. I think it is a fascinating question. Glucose being there, ribose being there, we had the potential to support RNA life hypothesis, and then glucose supporting further development of protein synthesis, other aspects of life. It's all pretty cool. Yeah. Go Bennu! Woohoo! Yay, science. I love it so much. This is one of those fun stories. So let's take us away from rock candy, space rock, into the old, old world of Earth. Yeah. Researchers decided to take a look at dinosaur parts. They were looking at melanosomes, or these cells within skin that contain melanin for coloration. And within the scales and the skin surface, that the hardened skin surface of lots of creatures, we know that the melanosomes can lead to some really interesting coloration. And we know by looking at reptiles, at birds, at all sorts of organisms that are living now, that we can look at what's present in the cells and in the structures that we look at when we go, oh, that's a pretty bird with those pretty colors and the feathers. Oh, it's nice. We look at that and see iridescence or whatever, but when you look close at the components, there are very specific structures that lead to the coloration. They contain melanin, there are others that lead to, like I said, iridescence, other things. It's so very neat. So these researchers, they looked at fossilized dinosaur skin because, of course, that's what you want to do. Of course it is. So the Diplodocus dinosaurs, they never knew the scientists were coming. The researchers were looking at old samples of the fossil skin. These originate from juvenile diplodocids, and it's from the Mother's Day quarry of the Morrison Formation in Montana. They used scanning electron microscopy to look at the epidermal layers, and they were able to see two fossilized layers in the scales, and they had differences in their structure and their carbon density. There were microbodies in these epidermic layers, two of them, where historically looking at fossilized dinosaur scales, they've seen like one. They're like, oh, look, it is this particular oblong shaped thing that we think contained melanin. We call them melanosomes. And so this is where you have a shape of a thing. It's within a certain nanometer range that probably refracts or reflects light within a particular nanometer range. And it's like, oh, you can imagine what a dinosaur would potentially look like. The second disc is like platelets, or it's flat, and they think that it's or they say it's reminiscent, this is from their abstract, reminiscent of platelet melanosomes, but it's smaller. Platelet melanosomes have function in iridescence, in various aspects of, you know, making animals that we know today have different colors than just green, gray, or brown. So these different structures lead to different colorization in living extant organisms. And so they're looking at it and saying, what could they be leading to, and how could they be representing um, representing actual coloration in these animals? So I'm scrolling right now. There is a great image that I'm going to share. It's big. I'm going to scroll through this. But this image, they've done an overlay of the width of the structures in different width and length in nanometers of these structures in different organisms that we know the colors of. And so they've got the width and length of structures in living organisms that we know to be iridescent. Okay, the width and length of the structures they found in the Diplodocus skin samples do not they don't fit in that. So these structures unfortunately do not mean that we had iridescent juvenile Diplodocus dinosaurs, unfortunately. Oh my gosh. But then we also have colors like the penguins. They're in their own world, and they're still in their own world and don't really overlap with our Diplodocus. We also have black and brown and gray. And from what we can see, these kind of platelet melanosomes fit not quite in the brown and black and gray for some of the organisms, and they do for others. And so the samples, what they're suggesting is that maybe we had freckles. Maybe we had speckles. Maybe the juvenile dinosaurs weren't just a solid gray or brown like the little figurines of dinosaurs that you buy for like 10 cents each. Maybe, perhaps, they had more intricate coloration where there was speckling. So lights and darks, browns, grays, and some mixing of in between. So potentially, our and this is just Diplodocus, which are part of the sauropods of the dinosaurs, and maybe there's more, right? So these studies looking at fossilized skin could give us a real understanding, maybe even of the differences between juvenile and adult organisms, right? So these juveniles were speckled, but did they go into different coloration as adults, more consistent colorization? Or were there different colors more predominant in different areas of the body? Like we have freckles on our faces because that's in the sun. But anyway, yeah, freckled or dotted diplodocids. It's kind of fun. That is in the Royal Society Open Science this month. If you're interested, you can take a look at it because it's open access, which is pretty awesome. Who here likes dinosaurs? Do you like dinosaurs? I like dinosaurs. I like dinosaurs. I also like elephants. Elephants are very wonderful. One of the issues with elephants, aside from conserving them and making sure that we have wonderful elephant populations in the world, um, the problem with living with elephants is that they're large, they're rowdy, they have great family groups, and oh, they're smart. So when they see that farmers are farming, irrigating, they're like, "Ooh, easy access to water. Thank you. Ooh, easy access to high nutrient food. Thank you." So farmers and elephants have been at an impasse in Africa for years. Now, different countries in Africa have been using different mechanisms to be able to keep elephants away from these rural farming, these family farms, these places where these things are. One study by the researchers that this study that I'm going to talk about in a second are by they used flashing lights to keep elephants away. I mean, really, flashing lights are only going to keep away everything except for ravers and airplanes. The researchers who did this new study, which just came out in, I think it's the Pachyderm Journal, is where it has been published. Um, this study looks at elephants in Botswana specifically, which I think is kind of fun. Anyway, the elephants in Botswana, the people in Botswana are having issues with these wonderful elephants because, of course, they're coming and they want to eat the food and they want to use the water and they're trying to do these, take advantage of the resources. How do you keep the elephants away? Well, one of the other mechanisms that had been tried in Kenya and some other places is using African bees, or at least the sound of African bees to keep elephants away. And so the researchers were like, "Hey, maybe what worked in Kenya will work here in Botswana." And so they were like, "We don't actually have bees to use to try and keep the elephants away, so we're gonna use recordings of bees." Bzzz. So they recorded hives of African bees and played the recordings at the edges of these different, farm areas, or played them, near these elephants and the family groups to see how the elephants would respond. Kenyan elephants did not like bees. They went away, they did not approach, they're like, "Bees? No," and none of them. Like, it was massively successful across the board, easy way to keep elephants away from your farm was using the sound of African bees. Botswanan elephants, however, it was a mixed bag. Some families they did not like bees and they decided they had to leave and they were not interested. However, others did not care. They had no care for the bees. What is that? I don't and these are not deaf elephants. These elephants are very abled hearing. Anyway, the elephants didn't care about the Botswanan bees. And so this is actually a story less about how the bees weren't a repulsing factor to elephants, but more the questions that came to the researchers as they kept going. And the questions that came to the researchers were, why aren't they afraid of the bees? Why don't they not like the bees? Nobody likes African bees. African bees can be mean. It has to do with how many bees are in Botswana. So in Botswana, there is an issue with the prevalence of bees and bee colonies. And so potentially the elephants and many of these family groups of elephants have never had a problem with bees before. Whereas perhaps in Kenya, where the majority of elephants did not like bees, they've all had negative experiences with the bees. Here in this particular situation, they're seeing a situation where it's a mixed bag and actually a lot of the elephants could care less about these bees that would actually be a really negative experience if they were to interact them, to step on a bee near a hive, bee near a hive. Anyway, they they want to do more research to find out exactly why, but what they've discovered is playing sounds of beehives in Botswana is not going to keep the elephants away from any hives, and it's the beginning of more research. Would you believe it? How elephants could lead to more bee understanding. That's where we've gotten. That's where we are now. How are we all? Yeah. Oh, I'm going back to the chat here. Cord143 is mentioning infinite diversity with spin mechanics and lighting effects back to the dinosaur dots story, right? So, um, lighting effects, the spin mechanics of the molecules, the components of whatever those small platelet melanosomes may have been. It's an interesting question, but we do know that, like, within a particular size range, you're going to get a certain shift in the light. I don't know. Maybe there were iridescent dinosaurs. But now I do believe I'm sorry. I love bee puns. I really do. I love dinosaurs and I love bee puns. How many of you had dogs when you were growing up? Here in the US, there is this stereotypical kind of nostalgia story that is oh, if you are growing up, it's the man and his dog, the boy and his dog growing up together, and, the good feelings that having a dog when you're growing up is going to lead to a good person. That if you grow up with a dog, you're going to have these great experiences. Um, and potentially, I mean, I don't know, there's this very positive story, this narrative that we tell related to people and their dogs growing up. But what if it were more than the dog that led to the person being mentally healthy and capable in life? What if it were not just the dog, but the dog's microbiome? So, understanding that dogs alter the and humans have a Kevin Reardon, I like gerbils. Okay, fine. Well, you have gerbil microbiome. Anyway, the researchers publishing in iScience this last week their study of adolescents and dogs. They looked at the microbiome of dog-owning adolescents. These are teenage cohort participants, about 345 individuals who were a part of this. And they found that dog-owning adolescents, those teens with dogs, had better psychological scores for mental health. Some commensals, microbes, were also correlated with the adolescents' psychological scores. And they went, huh, maybe it isn't just the dogs that are good. I mean, maybe it's just the kids. Maybe it's just the kids and just the situation. Who knows? But we have this correlation. So let's look at this. So they swiped germ free mice with the microbes of dog owning adolescents. They took mice who did not have any microbes and were living their lives doing whatever it is that germ free mice do in a cage. And then they didn't just give them adolescent child dog microbes, they also put them in a cage with another mouse, a trapped cage mate who was experiencing distress. The germ-free mice tend to approach those trapped cage mates less often when they're germ-free. Mice treated with dog-owning adolescent microbiomes, they approached their distressed cage mates more often. So we have a relationship between the microbes from the dogs and pro-social behavior of mice that is also, correlated to happier, mentally healthy adolescents. And then they were like, "What's involved?" And they did pin it down to streptococcus bacteria, particular group of bacteria within the microbiome, which is actually pretty interesting. They haven't gone, super deep yet, but this is a very interesting question because we know that microbes on our skin, within us, that they release compounds that can initiate chemical activity, that can initiate, they help our guts. It's not just that there's microbes there digesting things, it's that there are metabolites there that help. For beneficial bacteria, a lot of times they're releasing things that our body can use. So that's really great. So is this a particular group of bacteria that is releasing something that leads to the body releasing more happy making uh, compounds, or is it something that's different? What is happening? Can we wipe the microbiome of dog-owning happy adolescents on people and see a difference? No, I don't think we can, but, this is where that research is going. Are there aspects to this interaction that we can use in a targeted fashion moving forward? And then we just have to think more happy thoughts about kids with dogs and their germs. Yep. "Hi, dogs. What's going on?" "Yes, adolescents who own dogs are happier, not just because of the dogs, because of their germs." What if you changed the germs on the dogs? I think that's another question. I think that's another question. Anyway, we have some interesting work here, researchers pulling out the threads of understanding of our world. Kevin Reardon is saying way too many variables, but that's the point of breaking it down into scientific study. If you can control variables, if you can vary certain variables, right? Variables are the things you vary. Um, and you know what you're doing, how you're doing it, and what's not being changed, then you can get a better, fuller picture of how it all works. I don't know. Maybe someday we'll have dog germ antidepressants. I don't know. Is it because the kids and the dogs are out running in the dirt, going for walks? The dogs are like, is it because of outside? Or is it, specifically that microbiome? Is it specifically this is dog to kid, kid to happy? Yeah. There's work that needs to take place. If you are a dog to kid, a kid to happy, and you're happy to be here, even if you're a gerbil kid as an adult and you're happy to be here, thank you for being here. I am so happy to be talking about science with you and bringing these fun studies. These were my fun little easy stories. The next bit is going to be a bit more conversation, maybe, maybe some horror. I don't know. It's the holidays. I don't think we could do horrible stuff. This is This Week in Science. If you are just tuning in, thank you for joining us for this episode. Please tell your friends about This Week in Science. Share the links to TWIS. Get your friends to subscribe. The more people are learning about science, learning how to be curious and expand their understanding of the world and how science helps us understand the world and also innovate within it for society, the better we're going to be all together now. It's going to be good. Head over to twist.org. You can click on the latest episode for show notes and to listen to the episode after Rachel posts it tomorrow or as soon as she can. Additionally, we have our Patreon link and our Zazzle link if you're interested in helping support this show. Please click on those links because we are listener supported. Thank you for your support. We can't do it without you. All right. Now you want to talk about some things? Let's talk about some more things. So, Roundup, glyphosate. Oh my gosh. It was a while ago now, but this story came out of Retraction Watch and this last week, and I had to bring this week because it was a while ago when we had a conversation about glyphosate, and I was introducing a story and came into it going, "And, it's not dangerous to people and blah, blah, blah," and Blair and Justin both stopped me and said, "Wait, wait, 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 wait. No, no, no. Bad, bad, bad." Um, and and they gave a lot of evidence that is actually the predominant evidence, and I realized that I had read one review and it had confused me a bit, and that this one review article, it didn't say that it had been written by any employees of Monsanto. It didn't say it had been funded by Monsanto. It was a study, and it was, an article review. So all the articles, all the evidence, and yet the paper concluded that glyphosate's not harmful, does not pose a health risk to humans. And I read that story, and because I couldn't see the evidence of interaction with Monsanto, cherry picking the data, I didn't see the things, and it made me confused, and I was like, "Well, maybe it's not terrible." I don't I the international health groups have already said no. Right? So the International Agency for Research on Cancer, part of the World Health Organization, in 2015 declared glyphosate possibly carcinogenic, and I knew that, but this paper came out and it muddied the water for me. And as much as I try to stick to evidence and understand what's happening when something is not exactly your area of expertise, and something like this comes out that is not on the surface able to be denied, right? It makes it hard to deny it. And so when the last time we talked about glyphosate on the show came up and I started coming at it with a, well, and Justin and Blair corrected me. I'm glad they did, because Retraction Watch has published an article this last week about um, the now retracted article in Regulatory Toxicology and Pharmacology. It's an old article. This has been going on, this communication of evidence and and disinformation campaign of evidence has been going on for decades. The paper's been cited 614 times. However, there's some great research by Naomi Oreskes, Alexander Korov, and others, and they've published their findings. They published them in Environmental Science and Policy. They wrote to the editors of Regulatory Toxicology and Pharmacology. They wrote editorials describing the work in Science and also Undark. And the paper has finally, 25 years later, been retracted. The notice of retraction is more than 1,000 words long. The editors detail several critical issues that are considered to undermine the academic integrity of this article and its conclusions, such as the apparent contributions of Monsanto employees as co-writers to this article without acknowledgement as co-authors. There were also unpublished studies from Monsanto used in the analysis for this paper. So it's a review, a meta-analysis that relied on papers that nobody else could see. They're Monsanto papers, they're internal, unpublished. Anyway, these were the reliance for the conclusions that glyphosate exposure did not cause cancer. And so they did say this necessitates this retraction to preserve the scientific integrity of the journal 25 years later. Apparently, Naomi Oreskes and Korov in their analysis found evidence of emails between individuals within uh, Monsanto and uh, and and the writing group, and they found that there were these emails in which one individual proposed, I'm quoting from Retraction Watch right now, proposed keeping the cost down to produce a scientific paper with outside scientists, quote, by us doing the writing and they would just edit and sign their names, so to speak. Recall that is how we handled William Crowes and Monroe 2000. And there are links to these documents in Retraction Watch. So as wonderful as glyphosate is for getting rid of so many weeds in your garden, exposure to glyphosate is it's not safe. And this paper, apparently, this was ghostwritten by Monsanto employees using unpublished Monsanto evidence, and this paper was among the 0.1% of most cited articles on glyphosate. Hence my confusion, hence others' confusion. And so this, as Korov and Oreskes say, this is not going to erase 25 years of influence, but it's time to say that fraudulent authorship is unacceptable. So 0.1% of most cited articles. But this is a mea culpa for myself. And I honestly think it's very important for all of us to understand that we don't, you know, we don't know everything. There's experts in the field who are doing the work and they know the field so much more deeply than we do. So, misinformation. If I caused misinformation because I shared an incorrect view based on the study I read and how it shifted my views, I'm sorry. And I'm glad Justin and Blair took me to task. And actually, I think a lot of you in the chat room did as well. But this, it's part of the responsibility of scientific publications to take ownership of the mistakes in publishing that they have made. So this, I believe, is good, but it's like a correction in a newspaper or in a magazine. It's good to correct it. It maintains your credibility. People can look back at it. It's on the record, but at the same time, it doesn't have the same impact as that initial publication. So this is still going to be in people's heads, and unless it shifts from the citation index of papers, it'll still kind of be out there. So I think this is something that's part of our information awareness, that we need to be aware of these things, and we need to triangulate and really work together to ensure that we understand and have the broadest understanding of these issues possible. Anyway, I don't know. I hope everyone stays safe when they're getting rid of the weeds in the spring. Right now it's winter, so everything's gonna, at least in the northern hemisphere, and everything's going to be dead soon. It's almost the solstice. Oh my gosh. Speaking of dead things, how many of you have run across tumbleweeds when driving down American freeways? The middle of nowhere, suddenly massive tumbleweeds blowing across the road in front of you, almost as dangerous to play as Frogger, right? Well, some researchers, I think this is the interesting way this study goes. Some researchers published in Nature Communications their study that's inspired by tumbleweeds. The lead researcher, he was watching tumbleweeds and went, How does the wind blow them everywhere? How do tumbleweeds end up going to all these places? How have we not yet been able to make something that moves all over the place like tumbleweeds? Right? So the researcher took it upon himself and his lab to model tumbleweeds and try and figure out how to make a better tumbleweed, because of course it needs to be a robot. And this is where we are now. We are in the world of tumblebots. So these tumbleweeds, the researchers were able to take a look at how tumbleweeds moved and the physics of the movement of tumbleweeds. So how does a chaotic ball of branches, twigs, seeds, leaves, how does it create more drag than a solid sphere or any other kind of sphere that we have created to this point? And so they used modeling computational fluid dynamics, wind tunnel experiments to study their aerodynamics. They determined the porosity of the tumbleweeds, where there's a vertical porosity gradient. And what does this mean? It means that there's a different amount of, like, pores, right? How much wind can get through from the bottom to the top. 60% porous at the top, 40% at the bottom. And if you look at a tumbleweed, it kind of makes sense, because a tumbleweed has branches at the bottom, and they expand outward in a branching pattern, kind of into a ball, um, as the branches move. And so they were able to model this and say, how can we build our own? And they actually created a little ball built of plastic that they ended up putting a drone inside of because, of course, you have to put a drone inside of a tumbleweed to make it work better. And they were able to create a tumbleweed that this ball, it actually moves better than a tumbleweed. So it moves faster and can go uphill all on airflow, just the wind lifting it and moving it because of the way that the porosity and the differentiation of the fluid dynamics creating a differential flow over the surface. So it leads to the rolling of the ball, even uphill. And the researchers from there were like, okay, well, what if it bumps into a log? What if it rolls into a river? What if it, all these scenarios? And so they said, well, if we are going to create our Tumblebot, and they're not calling it that. I called it that because I think it should be called Tumblebot. But they modeled this thing and created it and tested it in the world using a drone inside of the bot so that the wind would blow through the tumbleweed structure, the Tumblebot, get it to roll. And then if it ran into something, had an issue, they could use the drone to move it forward just enough to let the wind take over. In some situations, they could create enough lift so that the tumbleweed would fly, which is different from normal tumbleweeds, except in a hurricane, right? Um, but the tumbleweed with the drone inside could take lift and take wing and get to the air. So it's an interesting situation where we could potentially be using this new design to what they're suggesting. They don't have autonomous control yet. So this is remote controlled drone inside of a tumbleweed. If they could make it autonomous, initiate swarm cognition, so where there's a bunch of tumbleweeds and they talk to each other and are able to move through an area based on where they all are and what's going on in the environment. And then additionally, with a bunch of sensors, we could release tumblebots into the world and they could be environmental sensors in situations of chemical leaks or I don't know. Who knows why you would wanna put a fake tumbleweed into the world? Who knows why you wanna do that? But, um, that's what there are lots of reasons that an engineer would want to put a tumbleweed into the world, but why not? I mean, we put cameras on cats, we have drone imaging of, all sorts of landscapes, but what about a tumbleweed's perspective? Rolling through the sand, traversing water, traversing obstructions. It's pretty amazing too, because they were able to, with the passive wind locomotion, get the majority of distance in where they were going. But the active locomotion, they were able to, save battery, be able to not use the drone the entire time. And so they think that with a quote unquote smart system, an autonomous tumbleweed could potentially last for a very long time in an environment into which it's released. Yeah. Anyway, the tumbling tumbleweeds of technology. We are here now. Tumblebots. Oh, Kevin Reardon. Yes, that's what you said. And this is a great thought. And this is one that was in my head earlier, and I totally forgot about this. We put tumbleweeds here on this planet and we could, but what about Mars? Why have a robot necessarily if you have an autonomous tumbleweed? Mars has incredible winds. The winds would definitely throw the suckers around, but could you imagine the mapping, the sensing, the understanding of that alien life, landscape that we would be getting? I think it would be I think it would be amazing. I think we should put tumblebots onto other planets. At least other planets that have wind, right? It'd be good. It could work, huh? Yes, release the tumblebots. I mean, I swarm technology is a little concerning to me, but there's it people have been working on it for years. There's a wonderful group that used to go to Maker Faire with their swarm robots, and they're beautiful. The technology behind them is amazing, and the idea of being able to have these an organism really that communicates, is able to cover a landscape in a period of time. It doesn't have to be people. It could be in a dangerous situation, right? It could be a swarm of robots. And if they're all communicating and sharing location, sharing sensor data, they can acknowledge what is happening and where. Maybe some of them can help each other. Maybe they can cover ground that others haven't. There's a lot to where these swarm bots could be really helpful in our understanding and exploration of our solar system and beyond. But yeah, make it a tumbleweed. It doesn't have to be any remote. Make it not heavy. Make it something the wind can blow. I think that is actually it's a really interesting idea. Okay. I only have one more story, and then we can either talk or um, not talk or whatever. Let's get ready to tumble. Exactly. That is exactly what it is. And now I bring you wait, where are my pictures? Here we are. Now I bring you I'm gonna scroll. I'm scrolling. Here we are. Here's the image. This is what I wanted to share with you. Everyone. I give you 3D necroprinting. What? What's necroprinting? What? Okay. So we've talked about some of the necroengineering that has been done using spiders, spider legs, other insect organisms with hydraulics and other biological morphologies or structures um, and forms that could be useful in engineering. So this group published in Science this last week their work on using a mosquito proboscis to make a necroprinter. So they were inspired by the idea of necro design. And so they said, we want to do better 3D printing at nanoscale or micron scale. And what could we use? Let's look around at different proboscises. Yes. Yes. They took a proboscis from a euthanized mosquito and they glued it into their 3D printing setup, which is a very like fine detail, high resolution 3D printing setup. And they were able to use the mosquito proboscis to do some really high resolution work. The This 3D necroprinting, oh my gosh, it it can do fine printed lines as fine as 20 microns. This surpasses commercially available 36 gauge dispense tips by 100%. It can withstand internal pressures of approximately 60 kilopascals, and so you have great fluid extrusion. However, if you have a more pasty 3D printing compound, it's not going to work great because that's be higher pressure and it's not going to come out the little tiny tube as well. They were able to create honeycomb structures, a maple leaf, bioscaffolds that could encapsulate cancer cells and red blood cells. They say that this work paves the way for sustainable and innovative solutions in advanced manufacturing and microengineering because we all know that mosquitoes are everywhere and we need to do something with them. No, that's hyperbole, but it's such an interesting idea. Like, I'm out of printer tips. Let me get a mosquito. Who thinks that? So anyway, necroprinting, it's for you now. The line width is as fine as 20 microns. Yeah. So let's talk a little bit about the dimensions of this particular dispense tip, a biological micro dispense tip, which is the proboscis of a mosquito. The female proboscis length is approximately 2 millimeters. It has a stiffness of approximately 200 millipascals, and this is like common plastics, not metals. Um, and they did pressure tests and found that it made it through burst pressure tests to 708 kilopascals. But when it came to the inks, it was a different situation. So, with this, let's see, what would the internal diameter be? So, from syringe or needle tip, we have different measurements here. It's tiny. I know, it's super tiny. Um, and when it ruptures out because of pressure differences, the high pressure within the proboscis, it ruptures out the side like a little balloon. But they were able to measure the force that the proboscis were capable of withstanding, and it was significant and capable of of putting up with most materials that we would be using for extrusion. Like, there's a lot that are not, but this was really good. So let's see, velocity. They have nozzle velocity. They're able to work out some really beautiful designs. Like I said, these honeycomb designs, um, and designs for cell culture, which is pretty great. But they looked at claws, harpoons, fangs, stingers, and then they decided that fluid withdrawing insects do the best because the injecting insects do a short burst of injection, whereas those organisms that are withdrawing fluid are withdrawing it for a longer period of time. And so they looked at plant xylem vessels as well, but they found that insect proboscides are the best, and the female mosquitoes was optimal. So here we go, Aedes aegyptis. Here we go. Inner diameter in microns is just over 10 to the 1. It's yeah, between 10 to the 1 and 10 to the 2 microns. Tiny, 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 tiny. So if you really want small, fine lines in your printing, maybe you need a mosquito. I don't know. Yeah. But I think this is really interesting because it's using biological structure. And to date, I don't think I've heard of anyone trying to use insect proboscis to do anything related to injection or suction or anything. So, I mean, it's a very interesting, we have our practices of needle pulling and creating the tips that are micron wide or whatever for our laboratory practices. There are standard practices to obtain these structures of glass in the lab. Um, but to be able to get something this small, now I wonder if mosquitoes and mosquito farming might not become a actual an actual trade moving into the future. How will laboratories be interested in mosquito proboscides? Are they going to look at how they can develop their own mosquito proboscides? And I didn't know it was proboscides until I just was really reading this right now. Is it proboscides? I like that. Um, that would be using language. That's my story, though. That's it. So, if you were able to get cells or structure, like structural material, compounds to flow from your very, I mean, you have to have a very, very high resolution, non vibrating um, 3D printing setup to begin with. You cannot have the one that is in the basement of my house right now. But if that kind of a needle, it's such an interesting idea, and I honestly love the fact that they were like, "Yeah, glued it we glued it to our setup and it worked. We just put it in there and we glued it and it dispensed our printing material in these micron widths, which is amazing." Anyway, necro printer, who knew? Dead insects, they're a thing now for engineers. Necroneers. Oh no, I should not have said that. Yeah, it's a very interesting setup. I am interested to see, like, some of the necro uses of insects to date have been, to me, they seem a little sensational, but often some of the work that comes out, it's sensational to begin with, but it has a very basic physics engineering underpinning, and it leads to something else, right? How can you design something? It's understanding the principles. How does it work? Why does it work? It's not, oh, we're just going to use dead insects to do, our claw toy now, right? We don't need a tarantula claw toy. But the idea of this particular mosquito work is, I think, fascinating, and I'm interested to see where they go with it. Some studies go places, others are just going to end up in uh, the Darwin Awards or wherever else. But is this the kind of biotic material that could lead to advancements in engineering? Is this the kind of biotic material that we cannot replicate? Is this the kind of biotic material that will actually be useful and not just be a gimmick? And I think these kinds of questions are very important. And of course, in the work, they're showing the value of it, but it's, I think, an interesting question. In the discussion of their paper, they say the glass-pulled dispense tip proves to be the only competitor capable of surpassing the resolution capabilities offered by the female proboscis dispense tip with printed filaments achieving line widths of less than 1 micron. But if you're in the jungle and cannot pull glass for your own dispense tip, and they're extremely brittle, they're hard to work with, and you've got lots of mosquitoes, maybe this'll work better? I mean, this is such an interesting look at the world. And they say this work validated the feasibility of using a laboratory-grown, uninfected female mosquito proboscis as a dispense tip for high-resolution printing, showcasing its potential as a low-cost, environmentally sustainable alternative to conventional metal and plastic dispense tips. They also suggest other alternatives. Although the female mosquito proboscis is better, assassin bug proboscides, bed bug, tsetse fly, sand fly, and aphid proboscides. They all offer an internal diameter of less than 1 micron, and they are easier and less expensive to fabricate. I think I'm just like head desking right now. But anyway, Hey, everybody. If you're doing some great printing work, grab a mosquito proboscis. It's going to be great. I really do love that study. What are we doing, you all? Where are we going? What's going on next? I've done my stories for the week. I'm trying to be optimistic. Everything is good. Blair is not here, and I miss her. Justin's not here, and I miss him, but I'm really glad that you're here. Thanks for being here in the chat room. Thanks for being here for the show. Thanks for talking about science and enjoying the science with me. I do, I rolled through the stories this week. It's not as big of a conversation, but I hope you enjoyed all of the science that I brought to the show tonight. Shout outs to Fada. Thank you so much for your help with social media, show notes, all that you do. Gord, Arnlore, others who help in the chat rooms. Thank you for keeping the chat rooms great places to hang out. All of you who are in the chat rooms, thank you for making sure that we have compassionate and respectful places to talk about science. We can disagree amicably. That's right. Tom Merritt said that to me today, and I liked it. So, yes, amicable disagreement. Yes, Rachel, thank you for editing the show. And Paul, thank you for recording the show. And of course, it's time for me to thank our Patreon sponsors. Thank you to Aaron Anathema, Adam Mishkan, Alan Viola, Ali Coffin, Andrew Swanson, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Dana Lewis, Daryl Myshak, Dave Wilkinson, David Youngblood, Don Mundis, Jonathan Stiles, aka Don Stylo, EO, Eden Mundell, Eric Knapp Flying Out, Fredis 104, G. Britton Lattimore, George Chorus, Greg Briggs, Jack, Jason Olds, John Atwood, John McKee, John Ratnaswamy, John Gridley, Ken Hayes, Kent Northcote, Kevin Parachan, Kevin Bridden, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hessenflow, Mark Jenkins, Noodles, Patrick Beccarao, Paul Disney, Paul Ronovich, Philip Shane, Pierre Villavzarb, Richard Badge, Robert Norland, Robert Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clarence Lamb, Shubrew, Stephen Alberon, Steve Leisman, aka Zima, Sue Doster, Teresa Smith, Tony Steele, and Vegard Shefstad. Thank you for all of your support on Patreon. We really can't do it without you. And if any of you are not supporting us on Patreon, you can head over to twist.org and click on the Patreon link if you're interested in supporting us in an ongoing fashion to make sure that we're able to bring you episodes week after week. We want to grow. We have a lot for people to know. We want to keep going, and your help really makes that happen. On next week's show, we will be back, hopefully with Blair, on Wednesday at 8 p.m. Pacific time, broadcasting live from our Twitch, YouTube, and Facebook channels. If you want to listen to us as a podcast, you have to search for This Week in Science wherever podcasts are found. And if you enjoyed the show, make sure you get them to subscribe to the show as well on whatever platform is their favorite. Ask them if they listen. Are you subscribed? Let me help you. Click, click, ding, ding, notifications, happy times. For more information on anything that you have heard here on the show, I've mentioned before, show notes and links to stories are available on our website, twist.org. And you can also sign up for our newsletter. Blair's newsletter? I don't know, someone's newsletter, our newsletter that we will send out with a wonderful, valuable thing at some point in time. We love your feedback. And if there's this topic or Hi, everybody. Am I here? Or am I here? Am I back? Oh my gosh, my computer crashed. I didn't mean for it to be over already. Thank you. I know. Uh-oh. Am I back? Thank you, Brian Burwell. Thank you for that acknowledgement. I can't put my hands up here. I hit my little popcorn. My computer just fully shut down. Pew! And then there was a screen with all of the fan things telling me about the fans and how much. So I have a feeling that I've got a overheating issue that I need to deal with. But if somebody can help me work with my tough gaming card, which I use for pretty much everything. I think it's the main card, my video card. Anyway, that's what it was. Sorry that I went away because I was so close to ending the actual show. Thank you for wondering what happened and for waiting until I could actually reboot and come back. So I'm scrolling down because everything changed, but I'm back again. Back again. Yeah, I am. I'm coming back to talk about the end of the show. You can sign up for our newsletter. What was I saying? We love your feedback. If there is a topic you would like us to cover or address, a suggestion for an interview, please send us an email. You can let us know on a social media account, but email works. Make sure you put TWIS in the subject line so that your email does not get spam filtered into a tumbling tumblebot and it blows away on the wind and then it's gone bye-bye because then the drone goes and it hops over a log and that you never know where it's going to go. We look forward to discussing science with you again next week. I do. I know I really do. And if you've learned anything from the show, remember, it's all in your head. And yours, and yours, and yours.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views.
What I say does not represent your views. It represents mine. That's all. And my considered views, although sometimes there's less consideration than others. Thank you, everyone, for being here. Rachel's gonna be busy this week. Yep. I don't know why my computer decided. It's done this a couple of times recently, just decided to crash, and it feels like there's warm air coming out of it. So something is happening with overprocessing, or it's working hard, and I don't know why. It's probably because it's old. But not all of it's old. It's got new parts. I don't know. It's a Frankenstein. It is such a thing. Has anybody here seen the new Frankenstein? This is the after show, by the way. Anyone seen the new Frankenstein? I have not seen it yet. And I will say, and it could be a bad fan. We replaced it, but maybe I just need to replace it again. That the video screen that comes up when it decides to restart after crashing, it says I have all these different bands. I didn't know I had that many fans. So I don't know if I have that many fans. I don't know. I have you as a fan, do I not? But I don't know about those fans. Um, yeah, Frankenstein. Oh, Fada, you didn't like it. Oh no. So what I'm wondering, apparently, the director, who I love in terms of directing movies, he said basically in an interview, he said, "Basically, every movie I've ever made is Frankenstein," and that he has been obsessed with the story of Frankenstein for his entire life, and I understand that, but I'm fascinated, right, by that idea of now you get the opportunity to actually tell the Frankenstein story, and, how does it go? So I'm interested. Aw, thanks, Paul Disney. Aw, yeah. Just wave your hands just like that, and it'll cool the computer right down. It'll work, butterfly, quantum physics, all that kind of stuff. It's all about your intention. Ha, 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 ha. But I have loved the Frankenstein story for a long time as well, but, like, not probably to the extent that, um, Guillermo del Toro has, and right? It's Guillermo del Toro, but starting life as a young person, I got pulled into the whole story, and I thought it was a great horror story, right? Scary monster, right? But I didn't think of it from, like, the real implications for a long time, and it was couple of decades ago. No, 15 years ago now? I don't know. I got to lead a science salon night discussion of Frankenstein, and it was prior to that that I read Mary Shelley's story completely for the first time, and, like, that copy of Frankenstein is so highlighted and like, side noted. I had so many thoughts as I was reading Frankenstein, like, and that led to that science salon and getting to open up the conversations of, humanity creating God. And whereas Frankenstein was a monster based on, you know, dead necro engineering, right? We have we have AI, which is a different kind of Frankenstein. And so where we is it AI? It's not AI that's the monster, it's the people that created it, right? Who are the monster. The people who are creating these things to be in the image of humanity, to be in the image of man, and to take our place somehow. I've come to think that they need, like, some good humanities courses. Like, there is a real issue with the disdain within the sciences for the humanities. And this needs to be talked about more because it's not okay. Culturally within science, people within the sciences look down on, oh, those arts majors. And right, communication. Oh my god. Um, there is really, like, it's not okay. Like, there is an elitism to people who get into a science program that I got in because it's so much harder to get into this program. Like, what I'm doing is so much harder. It's a perpetuated internal validation, right? Like, we do math, you don't do math, we do math. But at the same time, where we are now societally within the United States, we are seeing the fact that scientists are not trained in the humanities. They do not understand how to be human. There are lots who are great, and I thank all the people who have been on this show to talk with everybody here. Um, but I think we need to get rid of the Frankensteins. We cannot have any more Frankensteins. We cannot have any more of the lone genius who does not know how to talk to people, who's angry at whatever, and so does work, throws himself into his work, and that is good. Now, this is my, soapbox for the night. This doesn't go in the podcast. This is just for you who are hanging out still. Um, but I this is something that I've been thinking about a lot recently, and I've heard from a number of people that there needs to be a real emphasis on soft skills, on humanities, social sciences, on philosophy, on history of science in the training of scientists, and that we've done away with it because of our insistence on pushing, pushing, pushing the skill, right? Pushing the skill, but not the understanding. And if you don't know where something came from, if you don't understand its history, you can't move it forward effectively. I don't know. People are dropping off right and left. Thanks those of you who are still here. Apparently people don't want to hear my my soapbox. You guys are great. Thank you for being here. Honestly, if you want to talk about something, I'm happy to talk about it. We don't have to talk about what I'm upset about and how I want to change the world. But okay, Brian Burwell. I haven't read Frankenstein, listened to it while working. Yeah, Frankenstein wasn't the monster. It was the people who thought Frankenstein was wrong. And it was also Frankenstein for starting the process in the first place because he didn't start it out of a good place. Fada saying, never before has there been a Frankenstein's creature that tried to talk me to death instead of just ripping my heart out. And he was so needy. It was the total emo Frankenstein's creature. Wow. Which makes you it's really going to the heart. So this what you're saying right now, put it with Del Toro's comment about this is something he's thought about his entire life. This story has kind of driven his storytelling, the monster versus not monster. Who's the monster, right? What makes something monstrous? And so he went I mean, did he double down? Like, I kinda with your caveat, Fada, I actually do want to watch it a little bit more now, like but I might not be able to watch it with my family. I might just have to do a solo movie watch, maybe with a Blue Sky commentary as I watch it. I don't know. Um, Brian Burwell, that's not to say they were completely wrong for thinking Frankenstein was wrong. So right, exactly. The people who didn't like the monster, quote unquote, what Frankenstein created, they thought what the creation was the monster, but the people were the monsters because the creation needed love. The creation needed connection. The creation was gonna be something made in the image of man, right? And it wasn't given what it needed to be able to thrive and to be fully human. It was never allowed to be fully human. It started with the man who created it, Frankenstein, monstrous initiation, right? The idea was that now, and then society judging the creation, but and it took a long time for them to judge Frankenstein, right? Like, but Frankenstein came to understand he did a bad I don't know, there's so much to that story. I really think, like, in terms of epic stories, Mary Shelley created something that is going to last, and the storytelling's good too. Like, it's not one of those, like, really boring old stories that, I can't even watch it. It's good. Like, it keeps you riveted. You wanna know what's gonna happen next. But, yeah. Paul Disney, thank you. You're enjoying the soapbox. Other lessons can be learned from Frankenstein and Jurassic Park. Stop doing unethical things just because you can. Right. Right. So technology and availability of energy and resources, they're letting people do things, right? And especially now with like this profit-oriented capitalist society where like venture capital is like, woo, we'll give you money, you build something, we make a little money, we bump it up, we do stock buybacks, we do all this. People made a bunch of money. Look at the market. That has nothing to do with our actual economy. It's a different soapbox. But there's right now we've got people who are going around the side of the ethical work within the scientific community because they are in startups. We've read dystopian fiction about this. We know it could happen. We know this stuff goes on, but the scientific community said, "Hey, let's stop making genetically modified babies. It seems like a bad thing." And yet there are American companies who are incorporating, they're startups still, but they are incorporating in places where it's easier to do what they want to do. They're getting venture capital money, private equity. Like we choose whether or not to allow ourselves to live in the dystopia of the future sci-fi or to create a better narrative. We choose. We cannot let people we can't let other people choose for us. I'm tired of that. I'm so tired. But I got lots of energy. I'm great. Everything's good. We're fine. We're gonna keep doing this. We gotta talk about things. Yeah. Fada. Okay. New episode of Down Cemetery Road. You're heading out. Good night, Fada. Thank you. Thank you for everything. What am I gonna watch next, everybody? I've been enjoying Acapulco. I think Acapulco is the best. If you haven't watched it, it is Apple TV, which for some reason never remembers what things I've watched recently or not. It is not personalized anymore at all. Don't know why. What's going on there? Maybe I should talk to Tom Merritt about that one. I don't know. Um, yeah, Acapulco. It's funny, thoughtful. There's beautiful storytelling. It's great script writing, great characters, super enjoying it. It's like a positive thing in the world. There's like a few things that are nitpicky, of course. I can always come up with nitpicky things, but like the overall take home is that it's a good show. And I really like it if you haven't seen it. It is not sci-fi. It's in the 80s in Mexico. And it's great. I really like it. It's in Acapulco. Acapulco. I do not know if I'm gonna watch Frankenstein. I really, really want to, but I'm also so tired of sad and dystopia. What can we do, everybody? How can we fix it and make it better? What you all can do so that I don't soapbox anymore is get on social media and wish Blair and Justin happy birthdays over the next couple days because it's their birthdays. I miss them. I think Blair and I will be back next week. I don't know what we're going to do about our end of year review show. The schedule for Justin doesn't match up with our normal Wednesday night thing, so we might have to record that separately. If we do a separate recording, it will be live. It just won't be Wednesday night, but then we would be sure to play it during this Wednesday night time slot so that everybody can watch it when they like to watch it. But yeah, I have some scheduling things to work out. We do our normal things, but the people I do the normal things with are doing other things. So I'm going to keep going with the things. How would you feel about some interviews with people during the day, kind of, not during the normal TWIS hour, but adjacent to science. So information, misinformation, civic science, things related to us existing as humans in the United States. Because I have a few people that I'd like to talk to, but they don't fit within this normal TWIS time spot. And so Paul says yes. Okay. So I've been thinking about scheduling a few extraneous interviews of topics that are related to science. It is the importance of science with society, but it's also the connections of science with society, not the research itself or that development aspect, but more so the conversations related to, how do we ensure that we are supporting what needs to be supported, what we believe in, how what you believe in, right? So each of us have our own set of ethics, morals, um, and how do we ensure that we are supporting those things? Understanding the modern information environment, also talking about new initiatives like civic science, which is something that I was like, of course, this should be a thing. It's civics, people within government, like self-governing civics, taking care of each other, but science also, because that's part of it, because science is part of taking care of each other. So how do scientists talk to people, and then people in communities talk back to the scientists so that civically science is moved forward based on the needs of people? Like there's some really cool things that are out there that I want to talk about. Um, they're just a little adjacent. And I also want to talk more about science communication because I love talking about science itself, but my big focus the last few years has gone more and more towards the actual communication of science and how do we help creators do a better job. There's a PBS News special that came out today, if you're interested in it, that was great. It was okay, it was okay, but they're talking about we talked with influencers and information researchers, talking really about how do we deal with misinformation about science? Ah, as but it was great to see it discussed on a public forum as opposed to just within academic bubbles or wherever else it's been. So, I recommend the PBS News science thing. Johansson, Raven the Science Maven are in there. There's some really good creators they invited in, to talk about that stuff. I don't know, I felt myself going, "Ah, been there, done that," but maybe it is something that's for any of you who are out there interested in science communication or information and misinformation and the modern information environment, maybe there's some new stuff in there for you. So I recommend that as something to check out. It's 3 hours long. They did like a live Reddit AMA, answered questions from YouTube and all sorts of things. I think they did a good job. They could have done it better. I'm such a critic. Oh my gosh. You all are amazing. Yeah, let's watch Zootopia 2. I don't even think I've seen that yet. Okay. You're the best. You all are really the best. I'm gonna go. Maybe I'll watch Down Cemetery Road or an episode of Acapulco. Who knows? But we will be back next week. I'll bring Blair back. We're gonna make her come back so we can talk about science with you before the holidays. One more week before the holidays really get started. So I'm looking forward to it. And thanks for spending your time with me. I appreciate it. You're the best. This has been This Week in Science. Stay safe, stay healthy, stay curious, and stay lucky. Thank you, the Armando T. I'm going to go get some rest right now. Good night.